the next topic, that is cells, EMF and internal resistance of the cell. Okay. Now, the simple device with the help of which we maintain the constant current in the circuit, that is called the battery or cell. Here, one electrolytic cell is represented in the figure. In electrolytic cell, two electrodes are there. One electrode that is known as positive electrode, which is denoted by P. Another electrode that is known as negative electrode, which is denoted by N. And these two electrodes are immersed in the electrolytic solution in electrolytic cell. Here, we will not bother about the chemical reactions which takes place in this particular electrolytic cell. But just remember this thing, due to some chemical reactions between these electrodes and electrolytic solution, there will be the exchange of charges between electrolytic solution and electrodes. And due to that, one electrode becomes positively charged and another becomes negatively charged. Clear to all of you? Now, when this particular cell is not connected with any resistor in the outer circuit, at that time, whatever is the potential difference between these two electrodes, that is called EMF, means electromotive force of the cell. See, we discussed this thing, one electrode that is at positive potential because it is positively charged, another one that is at negative potential because it is negatively charged. So, when the current is not flowing through the battery or through the cell, સેલ તમે આવી રીતે આઉટર સર્કિટમાં રેઝિસ્ટર સાથે કનેક્ટ ના કર્યો હોય અને ક્લોઝ લૂપ ફોર્મ ના થતી હોય તો ઓબ્વિયસ છે કે સેલમાંથી કરંટ ફ્લો થતો હોય નહીં. So in that particular case, we can say the potential difference between these two electrodes P and N, that is V plus minus minus V minus. So V plus plus V minus, that is called EMF of the cell. So in short, you have to remember this thing, when the current is not flowing through the cell, at that time, whatever is the potential difference between two terminal of the cell or two electrodes of the cell, that is the EMF of the cell. But if resistance R is connected between these two electrodes in the outer circuit, and if the current I is flowing through this resistor, in that particular case, we can say the same current I that is also flowing through the electrolytic cell also. Now, when the current is flowing through the electrolytic cell, actually the current is constituted due to flow of charges, right? So here in outer circuit, the current is constituted due to flow of electrons. But inside the cell, the current constituted, that is due to flow of ions. And here, the motion of the ions from one electrode to another electrode that is opposed due to internal resistance of the cell. Suppose here internal resistance of the cell is R. So some energy loss will take place. Now, when the current is flowing through the cell, at that time, if we take the potential difference between these two electrodes, then that will be less than the EMF of the cell. And for that, we can write the equation V equal to E minus IR, where V, that is known as the terminal voltage of the shell. Clear to all of you? Now see, when current I is flowing through resistor R, then as per Ohm's law, we can write V, that is equal to IR. So here in this equation, if we substitute the value of V, that is IR, then IR equal to E minus I into small r. If we take this I into small r on left hand side and take I common, then we can write current I into capital R plus small r, that is equal to E. Therefore, I, that is equal to E upon R plus R. So here, this is the equation of the current constituted in this particular circuit through the resistance R, which one is connected in the outer circuit with the shell having EMF E. Clear to all of you?